In this session we would be understanding the concept of fronts in climatology. Now to start with, what are fronts? I can say they are sloping boundaries first of all. And why they are sloping boundaries? The reason is due to the Coriolis force that we have already studied in the previous session. So Coriolis force that tends to deflect the path of a rotating body, as we saw in the last class, explains the sloping boundaries of the front. So first of all, the first characteristic is it has sloping boundaries, and next important characteristics is there are two distinct air masses with contrasting characteristics. So I have two air masses and both the air mass have different characteristics. When two different air mass of different characteristics or contrasting characteristics come close to one another, what is formed is known as fronts. Now how can we understand these differences? These differences can be based on various parameters. I can say they can have difference in temperature, difference in pressure conditions, difference in wind patterns, difference in rainfall or precipitation. Then you have the amount of cloudiness, the location, and these are some of the characteristics that can differ for the two given air masses. And once we have two different air masses that are coming close to one another or converging, we have formation of fronts that takes place. Now front formation can be understood on the map and it can be located on the map. Here are some of the common symbols that we use on map to denote the four types of fronts that we will be studying in detail later in this session. So you have the cold front, warm front, occluded front and stationary front, and these are some of the conventional symbols that we use to understand these types of fronts. Now how do we locate fronts on a map? How can I say this is a region where there would be front formation? The answer to this problem is very simple. There can be few governing factors based on which I can say we can locate fronts. First is there is sharp change in the temperature. So if you have change of temperature which is sudden, you would have formation of fronts. Then you have change in moisture condition, again all the characteristics that we talked about. So change in moisture conditions, you have shift in the direction of wind. So you have shift in wind direction. That's again very important phenomena to understand the location of front on the map. Then you have changes in the pressure conditions and the amount of cloudiness or precipitation in the region. So these are some of the characteristics that help you locate a front on the map. Now, how does front formation takes place and destruction of front takes place? Let's first understand the related terminology. Creation of front is known as frontogenesis. Genesis means frontogenesis, so genesis means formation, and destruction of front means frontolysis. Lysis means destruction. So we have frontogenesis and frontolysis. Now for both of these conditions to occur, both of these features must meet two standard conditions. Now we will understand the conditions for both frontogenesis and frontolysis. Frontogenesis or creation of fronts is attributed to two basic conditions. First is two air masses of varying density come close to one another. So density must vary. That's the first primary condition. And if density is varying, that means one would be either cold and one would be hot. So there would be difference in the densities. And finally you have the prevailing wind or the existing wind that tends to bring them together. So prevailing wind is again important condition for formation of fronts. Now what are the two basic conditions for frontolysis or destruction of front? For destruction of front, the two basic conditions are wind is carrying the particle away from each other. So if the wind is carrying the particles away, there is separation of the air masses. So wind carrying particles away is one of the conditions for frontolysis, and another condition for frontolysis is difference in the temperature difference is disappearing. So you have disappearance of temperature difference. Now if I say both the conditions for frontogenesis takes place together, what would happen? There would be rapid formation of the fronts. However, if both the conditions for frontolysis takes place together, there would be rapid destruction of the front. So fronts, as I said, are non-linear. They can be seen in a zonal width of around 5 to 80 kilometers. Now this diagram shows the formation of fronts. What is happening here is, there are two different air masses that are converging. When they are converging, they move perpendicular to the axis and they move in this direction. Okay. Now what is happening here is, the flow is crossing the isothermals. So you have the isothermals here, and this flow is crossing the isothermals. And the region where it is crossing is not perpendicular to the isothermal flow. So the flow of wind is not perpendicular. So this flow of wind is not perpendicular to the isothermal, is again important phenomena, and the wind that is blowing is trying to oppose the existing air mass. So if this pattern takes place, we say frontogenesis takes place, and once frontogenesis takes place, you have a fully formed front that can be seen here. So this is a warm front where you have the warm air that is pushing up and you have the cold air, and on the other hand you have the cold front where you have the cold air superseding the mass of warm front. So this is how we understand the creation of fronts. Now how can we detect fronts? We can detect fronts in two ways. Now to make this easy, we can divide it into cold front and warm front. So if I say cold front, what I would do? I would again divide it into two, and then I have the warm front and I would again divide it into two. So I have the anticyclonic isobars here, and you have the cyclonic isobars. And again you have the anticyclonic and the cyclonic isobars that can be seen both in warm front and cold front. What would happen? In the cold front, when there is anticyclonic isobar that is behind the front, what would happen? That would lead to slow moving fronts, and these slow moving fronts would be the cause for the frontogenesis or the creation of front. What would happen in cold front? The reverse of what would happen in the warm front. So here anticyclonic isobars would lead to slow moving fronts and frontogenesis. Here cyclonic isobars would lead to slow moving fronts and frontogenesis. However, in contrast to that, in case of cold front, when it's cyclonic condition, what would happen? There would be fast moving fronts, and these fast moving fronts would ultimately lead to frontolysis or destruction of the front. And similarly here, anticyclonic conditions would lead to fast moving fronts, and that would again lead to destruction of the front or frontolysis. So this is how we understand or how we can detect the front formations. Now let's talk about the four basic types of front, that is the focus of today. So you have the cold front, warm front, occluded front and stationary front. Let's first start with warm front. What is happening in the warm front, as you can see in the diagram here? You have the cold air that is ascending over, the warm air that is ascending over the cold air mass, and that happens in the warm front. And this warm front, you have the direction of the front, which is this side, and you have the warm air which ascends over the cold air, and in other words I can say cold wedge in the frontal zone is retreating, or the cold wedge or the cold region air mass that you can see here is retreating and warm air is rising. Now these conditions lead to gentle rainfall. So when I say, when we talk about specifically about warm fronts, I can say rainfall is gentle. The slope is around 1:200, that is much more less steeper or gentler as compared to the cold front. So the slope is gentle. You have a slope of around 1:200, ranging from 1:100 to 1:400. Then you have the warm fronts which are less violent. You have light rains, it's less violent. In the next diagram you can see the formation of clouds in the warm front. So you have the formation of stratus clouds and finally leading to cirrus clouds in the warm front. When the warm air advances, you have the layered clouds, the stratus clouds, that changes to cirrus formations. So you have nimbostratus, altostratus, cirrostratus, and finally the cirrus cloud. We have talked about the clouds already in the previous session. Now these are the type of cloud formations that take place under warm current. Finally, during the warm current you usually see clear skies because there are light rains. You have clear skies, and frontal inversion also takes place sometimes near the warm front region. Now moving on to the cold front. What happens here in the cold front is, you have the warm air mass or the warm wedge which is retreating. You have the cold air mass that is pushing the warm air mass. So you have the direction of the front, and this is cold and this is warm. So you have the cold air mass that is pushing the warm air mass. As a result, it leads to formation of cold front. Since cold air is denser, it would tend to subside, and during the process of subsiding it becomes active. So you have a much steeper slope. As you can see here, the slope would be much steeper, usually at a ratio of 1:50 or 1:100 maximum. So you have steeper slope. Since the slope would be steeper, you would have fast moving winds that would be taking place. So front would move faster. As a result, you would have violent weather conditions. It might lead to thunderstorms. Cumulonimbus clouds formations can take place that can lead to heavy rainfall in this region. You would have also formation of squall lines that takes place here in this region. So if we move forward here, you have the cold front. So as the cold air is moving here, it's changing from the cirrus and the stratus clouds to cumulonimbus clouds, which is causing heavy rainfall or heavy downpour in this region, accompanied with lightning and thunderstorms. So that is how we understand the cold front. Now what is occluded front? Occluded front is if the cold air is moving and displacing the warm air, and finally the warm air is displaced to an amount that it moves away from the ground, we call it occluded front. So occluded front, I repeat again, you have the cold air, the cold front which overtakes the warm front, and it overtakes the warm front in such a manner that the warm air moves away from the ground. It is commonly seen in the regions of North America where you have the cold front occlusions that take place. And finally you have the stationary front. Now what is the stationary front? I have two contrasting air masses both of which are present in the region, but there is no ascent of air that is taking place. Both of them are running parallel to one another, but there is no rise of the air. So this creates a stable condition, or I could say a condition of stationary front is created, and winds from both the sides of the front run parallel to one another with no ascent of the air, and that is how we understand the stationary front. So with this we covered the topic on fronts. In the next session we would be covering jet streams and general monsoon conditions. You can subscribe to our channel for any further updates and let us know for any doubts as comments below the video. We will be more than happy to resolve them. Have a good day ahead.